Hello everyone, and this will be a class on the introduction to chemistry, the states of matter, the different states of matter of particles. So, without further ado, let's begin on this topic. So, this is a basic part of the CSEC chemistry, and we will be looking into fully what it is and everything about it for this class. I'll be mainly reading about it, and then from the chat you can ask questions about it, and I will be more than willing to answer. Particular nature of matter. Matter, as far back as 460 BC, a Greek philosopher called Democritus developed the idea that matter consisted of particles. He asked this question: if you cut a piece of matter, for example, a piece of gold in half, and then cut it in half again, how many cuts will you have to make before you can cut it into no further? Democritus thought that it ended at some point, the smallest bits of matter, and that these smallest bits of matter or particles would be the basic building blocks of matter today, or matter. Today, scientists have added to Democritus' idea and now describe matter and its property the particular theory or the particulate theory of matter. So now let's go into the particulate theory of matter. We discovered this, thing that right there. So into the particulate theory of matter. The particulate theory of matter states that all matter is made of particles. This theory is very useful because it helps to explain both the physical properties of matter and also differences between the three states of matter and the three states of matter, namely including water, liquid, and gas. Now let's look at what it means by that. The particular theory of matter has four main ideas. So let's try to at least think it a lot. Put it right here. So the first theory of matter: all matter is made of particles. All matter is made of particles. This is very simplistic. All matter is made of particles, and those particles are small things that make up it, right? The particles are in constant random motion, meaning they're going everywhere. There are spaces between the particles. There are forces of attraction between the particles. Theory of matter. There are four theory of the particulate theory of matter. Those four main ideas are: all matter is made of particles. The particles are in constant random motion, and there are spaces between the particles. And fourthly, there are forces of attraction between the particles. The particular theory of matter can be used to explain many physical, medical phenomenon that we observe in our everyday lives. Example of some of these are given in the next. This is the next page. All right here. So in relation to particulate nature of matter, the difference in density of solids, liquid, and gases. Example: why pebbles sink and bubbles rise in water. These are some of the basic questions that that particular theory can be used to explain, and it explains so how cooling a liquid can cause it to change into a solid. Like for example, this is freezing. Example: when water is placed in freezing, it forms ice. The particulate theory answers that. And thirdly, why a smell can move. Chicken is frying, it can be smelled at the other side of the kitchen. That is a great example of diffusion, meaning moving from a region of higher density to a region of lower density. That's diffusion in its full roots. So let's continue the class, and it's why the pressure of gas increases with an increase in temperature. Example: Cars tires get harder as you drive. And it also answers why certain vegetables become crispier when soaked in water. Example, raw potatoes and potatoes. And lastly, surface tension in liquid. Example, certain insects can walk on water. It explains all of these points, and it explains it well, very well. So let us try to recap what we did learn from this brief class. This will not be this will probably be a long class. I'll try to cover what I can cover. So state the three main ideas of the particulate theory. So if you go right here, we will figure out the main ideas. There are not only three main ideas, but there are four main ideas. So all matter is made of particles. There are forces of attraction between the particles, meaning that holds them together indefinitely. There is space between the particles. And thirdly, the particles are in constant random motion, meaning they're moving constantly and unexpectedly. So we'll continue. Hopefully everybody's okay. All right, good. All right, hopefully everybody's good. Hopefully, however, have a good day. Hopefully everybody's okay out there. Hopefully you're preparing for the CSEC chemistry as well as I am. So we can do this. Let's do this. All right, evidence for particular theory of matter. In the previous unit, we mentioned that scientists find the particulate theory of matter very useful because it allows them to explain the physical properties of matter. At the same time, those scientists have to provide evidence to support their ideas. There are simple practical activities involving diffusion and osmosis, which we can perform to provide evidence from the existence and movement of particles. Diffusion refers to the movement of particles from a region of higher concentration to a region of lower concentration. This is evidently seen when, for example, if we have a bottle of water, if we throw like for example a dye in that water, that dye will start from the top and eventually over a period of at least 2 to 3 minutes spread out. And when it spreads out, the whole bottle becomes contaminated and evenly distributed. That dye evenly distributes around that bottle you throw the dye, and that is why we see diffusion in its full length. So diffusion, according to the text, we all have had experiences of being aware of a smell, whether it is walking into a bakery, a cosmetic shop, or climbing into a car that contains an air freshener. All of these smells are produced at a point in the shop or car, but the smell seems to travel through the air. The smell traveling through the air is a result of diffusion. Diffusion occurs because particles of matter are in constant motion and will move from a region of high concentration to one of lower concentration. All right. So this example of a lab that was conducted with the main idea of understanding diffusion. This is what we consider to be chemistry labs. But aside from that, let's go into it. So we have a straw here. We have a beaker of water and a little bit of potassium manganate here, or crystals, we will consider it to be. So what happens is that if you put a straw and you put a little bit of potassium permanganate here in a magnet straw, eventually over at least a period of at least 2 to 3 minutes or a couple of seconds. After a while, the purple color spreads throughout the water. The water becomes a purple color throughout. The crystal, the crystal gradually dissolves and the aqueous solution is formed, i.e. solution where water is solvent. Figure 1.23 illustrates the process of diffusion occurring in the experiment. So number one, so we have the potassium permanganate. It's right here. Before dissolving, crystal particles pack closely together. Water particles moving at random with small space in between. Crystal particles separate from each other and diffuse into the spaces between the water particles, eventually dissolving over a period of time. and that is how diffusion works. So that will be everything from me on the study prep guide, introduction to chemistry, the basic states of matter, and what you need to know about it. Thank you.